Welcome to Chapter 10, Quadratic Equations, Intro to Functions. We'll finish up with a little bit of function information, but most of this chapter will focus on quadratic equations. We've done a little bit of these already. It just means when there's an x squared piece involved, what do? And in Chapter 7, we looked at using factoring and the zero product property to be able to solve for x to find out our answers. Here, we're going to be solving quadratic equations, but this time we're going to use what's called the square root property. Now, when you take what we know from Chapter 7 and what we're beginning to expose ourselves to in Chapter 10, there's actually going to be three different ways to solve for x squared. There's the factoring from Chapter 7, there's this square root property in Section 1 that we're going to look at right now, and then in Section 10.2, which is actually going to be a bonus. You don't have to do that one. You can do it for extra credit if you'd like. It introduces you to completing the square. Factoring from Chapter 7, great if it's factorable. Square root property, great if you're able to take the square root of both sides. However, the big payoff comes after 10.2 when we complete the square. It actually allows you to create a formula. The quadratic formula might sound familiar to you. That negative b plus or minus big old square root b squared minus 4ac, the whole thing over 2a, if that sounds familiar at all, that's the quadratic formula. So we're getting there. We're getting to where no matter what you see in the x squared, factorable or not, you're going to be able to use the quadratic formula to solve it. But we're working our way there, so we got to expose ourselves to all the possibilities so that when we get to quadratic formula, it's like, oh, finally, yes, now I've got it. I've got this one tool that I can use for all of them, if you so choose. So let's review just a little bit. If we have x squared equals to 100, there's two possible solutions for x. You could either get positive 10 or negative 10, because positive 10 times itself when you square it, that gives you positive 100. And negative 10, when you multiply it times itself, negative 10 times negative 10, when you square negative 10, that also equals positive 100. So when we're solving for x, when we have a quadratic equation, when we're solving for x, there's two possible answers. And what we did in Chapter 9 was said, well, if we got the square root of x equal to something, a number or another expression, we would undo that and get x by itself by squaring both sides, because to square something is the opposite of a square root. Well, same thing now. If we've got x squared involved and we've got x squared by itself, that's the key, then you can take the plus or minus square root of both sides. And the reason why we do plus or minus square root is because we have to guarantee, the plus or minus guarantees the two possible answers. Your positive root and your negative square root. Okay? So let's see what that looks like. Now again, if you're following what I said at the beginning of these notes, what we learned in Chapter 7 was we could solve an equation involving x squared by factoring. What we're exposing ourselves now to here is the potential that what if it's not factorable? It's still solvable by using what we call the square root property. Now we're going to build on that in Section 2 and Section 3. Section 2 is bonus. We're going to build on it, Section 2 and Section 3, by doing what's called completing the square, and it creates a quadratic formula that's going to work whether you can take the square root, whether you can get x squared by itself, whether the thing is factorable or not. It's going to work for everything. So that's where we're headed. All right, here's the instructions for some of these examples. Solve using the square root property, and a little typo there, an extra period. If possible, simplify the radicals or rationalize the denominators. So we don't want to leave, we want to put things in its simplest form, and that includes no radicals in the denominator. That's what that means. So we want to simplify radicals, and we want to rationalize denominators for our final answer. So the steps are actually off camera here. They're down at the bottom of the page. If you printed out the notes, you'll be able to see that. But we're going to get the x squared piece alone, and I'm having to fill in that x because it didn't print here. But we're going to get the x squared piece alone. That's step 1. We're going to take the plus or minus square root of both sides, and then we're going to simplify or rationalize as needed. So we're going to try to get this x squared piece all by itself. Right now it's being multiplied by 3, so we're going to divide both sides by 3, and that gives us x squared is equal to 25. Some of these you're going to be able to do in your head, but again, we're going to practice the steps even when the problems are easy so that we have the steps in place when the problems get harder. I'm going to go ahead and rewrite that again just to give myself some workspace and to make the notes extra clear what's going on. I'm going to take the plus or minus square root of both sides. When you take the square root of x squared, it just undoes it. Okay, nothing else happens. You're just releasing the x. You're just freeing it up to be just x again. We've undone the operation that was happening to it. It was being squared. We undid it with plus or minus square root. It just becomes x again. Over on the numbers, we've got plus or minus square root of 25 is 5. So there's two possible answers here. X equals positive 5 or x equals a negative 5. And so you could write that as x equals plus or minus 5, or you could write it as a solution set with the cute little braces. They look French to me because they're so fancy, but they're not really French. But they're the little braces here of negative 5 and 5. This is not the point on the graph, negative 5, 5. It is just a set of two numbers, and that's what the braces mean. So there's two possible answers here. Not as critical that you have to check your answers on these because, but always a good idea to check. But there's no possible chance for extraneous solutions. That's when you start with a radical in your answer. But always good to check here. If you put a positive 5, you get x squared is 25. 25 times 3 is 75. You put a negative 5, negative 5 squared is positive 25 times 3 is 75. So it should check out. It's a way to catch your mistakes by checking your work. Let's look at number 18. 5z squared minus 2 equals 0. What's different about this one than the one we just did? Well, it has 5 times a quadratic piece, a variable squared. There's also a minus 2. Okay, we can deal with that because our goal here is to get z squared by itself. So we're going to undo what's happening to the z squared. So just as if it were plain old 5z minus 2, we're going to add 2 to both sides, which gets us the 5z squared equal to 2. We're going to divide both sides by 5, which gets us z squared is equal to 2/5. We are going to take the plus or minus square root of both sides. I really should have left myself more room. Let's see if I can do that here. Plus or minus square root of both sides. The plus or minus square root has done its job. It has taken away the square, so that's all this does. It doesn't do anything else. It just releases the z, frees it up to just be itself again, just plain old z. Over here, we have plus or minus radical 2/5, and technically that is plus or minus radical 2 over radical 5. We have a radical in the denominator, so we need to rationalize that. We need to make the denominator a whole number. And that's something that we did again back in, did we do that? I think we did that in chapter 6, I want to say. Or maybe at the beginning of chapter 9. I'm getting my chapters confused, I apologize. But we're going to rationalize by multiplying top and bottom by the same thing, so that we're really just multiplying by 1. We choose radical 5 over radical 5 this time because that's what we see in the denominator. And so when we multiply it, that's going to become radical 25 or just 5. So my top becomes just plain, or I'm sorry, my denominator becomes just plain old 5 because that's what we intended for it to happen. It's still plus or minus out here. And then radical 2 times radical 5 is radical 10. So our final answer is plus or minus radical 10 over 5. Don't be tempted to take the 10 divided by 5. Radical 10 is like 3 point something something something. That does not cancel evenly with 5. So don't be tempted to take that 5 and divide it into the 10. It's not really 10. It's square root of 10. Totally different value. Okay? I'm going to adjust the camera so you can see those steps that we were talking through and the try problem. So there's our steps, and you'll notice I wrote in the x here. It didn't print off. It shows on my screen, but it didn't print. So get x squared piece alone, take the plus or minus square root of both sides, and then simplify and rationalize as needed. So take a moment to talk through what you just saw in those two previous examples, either to yourself or to someone else. It's a great way to begin preparing for the exam. Note any questions you have, bring those to class or to your help resource. And then try number 12 here, 16x squared equals 25. Remember that you want to make sure you do not finish with any radicals in the denominator. Pause the video, come back once you've done all that and tried it, and see how you did. Okay, and when you're all done, you should get that x is equal to a plus or minus 5 over 4. Plus or minus 5 over 4. Okay, we'll see you on page 2.